Hello Algebra 2, this is your Unit 6 review. We're going to start by simplifying some radical expressions. In number 1 we have a cube root, and so we're going to try to take anything out of the cube root we can. I'm going to start by making a factor tree for the number 56. So I can make that 28 times 2, and 28 can be 7 times 4, and that can be 2 times 2. So anything that shows up as a factor 3 times can come out because the index is 3. So I have 3 2's, that's going to come out. I already have a 2 on the outside, so this 2 stays, and then I take the other 2 out, and I'm left with 7 underneath the cube root. Alright. When you have a radical expression, that can also be written as a rational exponent power over root. So if the exponent divides evenly by 3, you can take that out. So 8 does not divide evenly by 3, and 10 does not divide evenly by 3, but 3 does. So the z's can come out completely. Power 3 and root 3, so 3 over 3 is your exponent. Alright, for the x's, 8 does not divide by 3, but 6 does. So I can change this to be, let's see, x to the 6 times x to the 2. And that way I can take out the x to the 6 because that divides evenly by 3. And then the y to the 10 can be y to the 9 times y to the 1. And that's because 9 can divide by 3, so that can come out. So let's simplify what's out here. 2 times 2 is 4. Z to the 3 over 3 is Z to the 1. I already dealt with the 7, that's going to stay. Now for the x's and for the y's, I'm going to take this one out, and I'm going to take this one out. So this is going to become x to the power over root to the 6 over 3. And then the y is going to become y to the power over root 9 over 3. And everything else is left underneath the cube root. So you have cube root 7 x squared y to the 1. And now let's see, I have a 4. Z to the 1 is just z. 6 over 2 gives me x squared and y to the 3, and then I have this radical. Okay, next one, these are adding and subtracting. You can only add or subtract if you have like terms. So I'm going to see if I can simplify any of these radicals so I have like terms. 15, that's just 5 times 3, and those are both prime factors. They don't split up anymore, so I cannot simplify square root of 15, but I'm going to work on this 75. So 75 is 3 times 25, and 25 is 5 times 5. So I can take the 5 out of this. So I have 5 root 3 minus root 15 plus 3 root 3. So this root 15 has no like term, it's going to stay in your answer, but you can combine 5 root 3 plus 3 root 3 and get 8 root 3. So your final answer should be 8 root 3 minus root 15. Alright, if you have two radicals with the same index, and often the index is written in here, but if it's a square root, the 2 is just assumed. Then you can multiply the radicands, you can multiply what's inside them. So that's what we're going to do. 3 times 21 is 63, and when I multiply x to the 5th times x to the 3rd, I add the exponents and I get x to the 8th. So 63, I'm going to make a factor tree to see if anything comes out. That would be 9 times 7, and 9 is 3 times 3. So because the 3 comes up twice, that comes out and leaves the 7 underneath. Alright, to take out the x's, I would do x to the 8 over 2. Remember, there's no 2 here. but you can imagine that it's there, and that is your index 2. So you have x to the 8 over 2, and it comes out evenly, so there are no x's left underneath. So I have 3 x to the 4th square root 7. Alright, in problem 4, you have square root of 27 over 3a, which is square root of 27 over square root of 3a. You could work on the problem this way, but actually it might be easier to just simplify 27 over 3 to start. I think I'm going to do that. Alright, so 27 over 3 is 9, so this is the square root of 9 over a. And you want to rationalize your denominator, so I'm going to multiply by root a over root a. So then in your denominator you have the square root of a squared, and in your numerator you have the square root of 9a. Well, the square root of a squared is just a, so now your denominator is a, and your numerator is square root of 9a. And this is called rationalizing the denominator, because you're not allowed to have a square root on your denominator. Alright, in this expression I'm going to deal with these 3's outside the parentheses first. This is a 3, this is a negative 2. So for this one, you're going to distribute it to the 2, and to the a, and to the b. So you'll have 2 to the 3rd, and you'll have a to the power to a power you multiply, so that's 15, and b to the 12. Okay, this one has a negative exponent, so you could just move this whole chunk to the denominator, if you like, and make it a positive 2. So it would be like this, 4a to the 3, b to the 7 to the positive 2. And then you could give everybody the 2, so 4 to the 2, also for the a, also for the b. So on the top, 2 to the 3rd is 8, a to the 15, b to the 12. On the bottom, 4 squared is 16. A to the 3rd to the 2 is a to the 6. And b to the 7 to the 2 is b to the 14. Alright, so 8 over 16, this is just a fraction to simplify. So 8 over 16 simplifies to 1 over 2. A to the 15th over a to the 6th, you want to subtract your exponents, and you get a to the 9. And for the b's, you also subtract, and because the larger exponent's in the denominator, that's where your answer will go. So 14 minus 12 is 2, so b squared. Alright. In problem 6, you could deal with the 4 first, or you could deal with the inside first. I think it might be easier to just deal with the inside first. So anything that has a negative exponent, I like to move that to the other part of the fraction so it becomes a positive exponent. So here's my fraction. Don't forget about your 4. The a to the 5th, that was a negative exponent, so it's going to go down here. B to the 7th is fine to stay up here. The 2 is fine to stay in the denominator. The a to the 1 is fine to stay there. And then b to the negative 3, that moves up here to become positive. Alright, in your numerator you have b to the 7 times b to the 3, which gives you b to the 10, because when you multiply you add exponents. This 2, I'm going to bring it out front here, and you have a to the 5 times a to the 1, so you get a to the 6th. Now you can raise everything to the 4th power. For power to a power, you multiply exponents, so that becomes b to the 40, and a to the 24. And then the 2 is raised to the 4th power, so 2 times 2 times 2 times 2, which is 16. Okay. So here, when you multiply, you have to add exponents, and that can be tricky if they're fractions. A is to the 3/5 plus 1/4. And B is to the 2 plus 5/2. So we're going to find a common denominator. For the first pair, your common denominator is going to be 20 because that's the least common multiple of 5 and 4. So let's see. If I want to change this to be over 20, I need to multiply by 4. So 3 times 4 is 12, and 5 times 4 is 20. If I want to change this to 20, I have to multiply by 5. So 5 times 1 is 5, and 5 times 4 is 20. And so then for the A, I'm going to get 17 over 20. For the B, this is not a fraction yet, but I can multiply it by 2 over 2 and make it a fraction. So B, if I multiply this by 2 over 2, I get 4 over 2. 5 over 2, which becomes B to the 9/2. Now, if you really don't like finding common denominators, you can add these fractions on your calculator. Let's see. So I'm doing 3/5 plus 1/4. 3/5 plus 1/4, and then you press math and fraction, and you can get your answer that way as well. All right, on page 2, we're going to solve equations, and you also want to make sure that you check for extraneous solutions. First one, we're going to square both sides to undo the square root, and now you have a simple linear equation, 3x minus 5 equals 7x plus 3. Then you want to get your x's to one side. And you want to isolate the x, so get rid of the 3. And divide by 4. So I have x equals -2. Now you want to check your solution to make sure that it works. So here's my check. Square root of 3 times -2 minus 5. And that gives me square root of -6 minus 5, which is -11. On the other side, you have square root of 7 times -2 plus 3, which is the square root of -14 plus 3, which is also the square root of -11. So because both sides are the same value, it works, and this is your answer. All right, in number 9, you want to get the square root by itself before you square both sides. So get rid of the -3 with +3. 2 square root 5x plus 1 equals 12. And then get rid of the 2 by dividing by 2. So square root of 5x plus 1 equals 6. Now you have the square root isolated, so you can square both sides to get rid of the square root. So 5x plus 1 equals 6, and solve for x. 5x equals 5, and x equals 1. All right, so now you want to check your answer. Put the 1 in for the x. 2 square root 5 times 1 plus 1 minus 3, and that should equal 9. 2 all right, square root of 6. So this is not working out, but I don't think it's because it's an extraneous solution. I think it's because I made a mistake. So I'm going to check back here, and I find my mistake right here. Let's go back to the blue pen. So 6 squared is actually 36. So when you subtract the 1, you get 35, and when you divide, you get x equals 7. So checking for extraneous solutions can also just find your mistakes. I'm going to rewrite that answer, though. X equals 7. Okay, so let's go back now and check this one. 2 square root 5 times 7 plus 1 minus 3 equals 9. So 5 times 7 is 35 plus 1 is 36. And the square root of 36 is 6. So 2 times 6 minus 3 equals 9. 12 minus 3 equals 9. So this is true. And your answer checks out. Alright, in problem 10, you are going to get rid of divided by 3 by multiplying both sides by 3. So times 3 times 3, that's going to cancel this out. And you have the square root of 4x and then a plus 7 equals 15. And now you want to subtract 7 on both sides. Alright, now to get rid of your square root, you can square both sides and you have 4x equals 64. And divide by 4 to get x equals 16. Alright, so now we're going to check your answer. Square root of 4 times 4 plus 7 over 5 equals 5. 4 times 4 is 16, and the square root of 16 is 4 plus 7. Oh, that was not a 5, that was a 3. Okay, so again, I think I put the wrong number up here. I'm supposed to put 16 up here, so this would be 4 times 16. I'll just start that over. So it's supposed to be square root of 4, and for my x I should put in 16. Plus 7 over 3 equals 5. Alright, so this is the square root of 64, which is 8. So I have 8 plus 7 over 3 equals 5. And 15 over 3 equals 5 is true. So this checks out. Alright. If you have a rational exponent, you want to make your exponent 1, so you're going to multiply it by the reciprocal. So if you have x to the 5/4, you're going to multiply it by 4/5. So that's essentially raising it to the 4/5 power, because if you raise a power to a power, that's when you multiply exponents. So you have to raise the other side to the 4/5 power as well. So this is going to give you x to the 20 over 20, which is x to the 1, just like you wanted. Over here, you have power over root. You have the 5th root of 32 to the 4th power. Okay, so the 5th root of 32, some number times itself 5 times gives you 32. And that number is 2. And 2 to the 4th is 2 times 2 times 2 times 2. So you get 16. Alright, now if you raise 16 to the 5/4, you can check your answer and see that that works as well. Another way to do this problem is on the calculator. So if you want to do 32 to the 4/5, you can do 32 raised to the parentheses 4/5. And also get 16. Alright, 12 and 13, convert to simplified radical form. So first we're going to convert it to radical form. The 8 doesn't have an exponent, so it stays out of the radical. And for the fraction, it's power over root. So your root is 3, and your power is 11. Now you want to take as many a's out as you can, so I'm going to take this and I'm going to split it up. I need something that divides by 3, so the biggest exponent that will divide by 3 that's less than 11 is 9 times a squared. So 9 over 3, cube root of a squared, and 9 over 3 is 3, so 8a cubed, and then cube root a squared. Okay, for this one, when you divide, you subtract your exponent, so you have x to the 4 minus 3/2. And to get a common denominator, you can multiply the 4 by 2 over 2. So you have x to the 8 over 2 minus 3/2, which is x to the 5 over 2. So now to rewrite it as a radical, it's power over root. So your power is 5, and your root is 2, and you don't normally write the 2 in there for a square root. You would for any other number, though. Alright, so I can't divide 5 by 2, so I need to split this into two pieces. I'm going to do x to the 4 times x to the 1, because now I can take this out. You do 4 divided by 2 because it's a square root, so x to the 4 over 2, square root of x to the 1, and it becomes x squared root x. Alright, same idea down here. To convert to simplified exponential form, you're going to take your exponent and go power over root. So a is to the 3 over 5, b is to the 15 over 5, and the c doesn't have an exponent, so give it a 1, and it's c to the 1 over 5. These two are already simplified, but we can divide 15 by 5 to get 3. So you have a to the 3/5, b to the 3, c to the 1/5. Okay. For this one, let's start by simplifying, because cube root of 8 is 2, so I can take that 2 out of the whole thing. So I have 2 cube root of x to the 4th. Now 2 to the 4th, 2 times 2 times 2 times 2 is 16. And I have cube root x to the 4th. Alright, so I can't divide 4 by 3, so I'm going to split this up. I have 16 cube root x to the 3 times x to the 1. And then this one comes out, so it's 16x to the 3 over 3. And the x to the 1 is still left underneath, and then simplify 3 over 3, so you have 16x cube root x. Let's see. But I was supposed to convert this to simplified exponential form, so I think, even though I did a great job simplifying my radical, that's actually not helping me right here. I want to go back to this step here, and I want to change this to my radical exponent. So it's power over root 4 over 3. So my final answer should actually be 16x to the 4 over 3. Alright, so that's where this video stops, and you're going to start up on the next video.